Hello everybody. So today we have finally got around to talking about design patterns, which I'm super excited about because we're talking about design patterns. It's exciting. We're moving on from the stuff we are talking about before, just normal programming. Now we're in design patterns. I was excited when I was learning this. I'm still learning some of them. So we're going to start with the Singleton design pattern. And I'm really excited to talk about this, not only because it's easy um, or an easy concept, but pretty soon I'm going to have enough topics that I've covered that I can combine them all. And I think I only need to do one more topic after the Singleton design pattern after this tutorial. And then I've already done polymorphism, and so I'm going to do one more. I'm not exactly sure what it's going to be. And then I think what I'm going to do to combine is we're going to combine polymorphism, the Singleton design pattern, and whatever else I'm going to discuss. We're going to find a way just to combine it, have a little bit of fun. So let's stop talking about that and start talking about stuff that we should talk about. First, I have to mention that I am not a professional. I am still a student going for my computer science bachelor's degree. So I have to put that out there. I'm not a professional. And I went back, I've listened to some of the tutorials. It is very obvious that I'm not a professional. I mix up my terms, I fumble my words. So that's probably going to happen in this time. So, fair warning. So let's talk about the Singleton design pattern. What is it? Well, you use the Singleton design pattern when you only want to have a single instance of a class. Another way to say that is it restricts the instantiation of a class to one object. And it uses lazy initialization. So what is lazy initialization? Well, it's the tactic of delaying the creation of an object or the creation of a value or some other expensive process until the first time it's needed. And when we start programming, because we're going to program these, then it'll all make sense. It'll all be right clear in front of us. We're going to go over two different types of Singleton design patterns: the classic Singleton design pattern and the Myers Singleton design pattern. One difference, or at least difference that we can put in words, is the classic Singleton is going to use a pointer. The Myers is not. We're actually going to make a reference to our class. With the classic Singleton, you can allow for inheritance, which we've talked about in the polymorphism tutorial. The Myers does not allow inheritance. So we're going to use the classic Singleton when I make my other tutorial and I combine a bunch of things. And I put not thread safe for classic and thread safe for Myers and question marks because I haven't really studied those aspects of singletons. And I think it's not thread, or what I'm going to show is not thread safe. You can make it thread safe. But since I don't know enough about those topics, we're not really going to talk about them. Just know that that's that's something else that goes a little deeper into the design pattern, is making sure they're thread safes. Because since we only want to have a single instance of a class, what if multiple threads are pulling this? Well, that's going to make multiple instances. So how do you deal with that? Well, that is for either other tutorials of people smarter than me, or me later on in my career coming back and redoing this and talking about those. So enough about that. Let's go here. And alright, so we have already our setup. So first thing we're going to do is we're going to do the Myers Singleton design pattern. So the Singleton design pattern, here, let's actually move this to this screen over here. So we only want to have a single instance of a class. How do we do this? So let's make a class. We're going to call you INGLE Singleton, Myers Singleton. Don't need that in a class. Alright, so this can be our Myers Singleton. What we're going to do is we're going to make sure we do public, and we're going to make a static member or a static function. And it's like this in all the Singleton design patterns. They all have static functions. Meyer Singleton. It's since we're using the Myers, we will use a reference, and I will call you either my singleton or call you instance. Call you instance. It's less characters than calling you my singleton. All right. So there we have a static function that's going to return a reference to our class. Static namespace, not what we want. Then we have we're going to make a static variable s, which is this class. We shall return that s. And there. So what happens when you call this function? Well, then you're going to call, or you're going to look at this created variable. Since we're doing it as static, it's only going to create one, and we will return it. And if it's already created, well, then we're going to return what's already created. It's not going to make a new one. So let's go private. And now what we're going to do is we're going to put our constructor, our copy constructor, and our overloaded assignment operator. We're going to make those private. The reason why we're making those private is so that the only way that you can instantiate this is going through this function right here. If we made them public, well, then you can instantiate this at any time. That's not what we want to do. Meyer Singleton. So go ahead and make our constructor. Go ahead and make our copy constructor. Why are you not? I did something wrong. I don't know what it is. Well, we're going to stay here till we figure it out. Myers Meyer Singleton. There we go. Alright, we figured it out. Good job, us. So this right here is our copy constructor. This right here is our constructor. Now we're going to do the overloaded assignment operator. Let's see if I can call this the correct thing. Hey, it likes it. And although it does absolutely nothing, this right here is the Myers Singleton design pattern. You can only create one instance of this. Every time you call it, if it's already created, then since we're doing this as static, it's going to give you what's already created. If it's not, then it's going to create it. And well, actually, we should make this do things, and we will. First, let's go ahead and let's do our classic singleton. So we're going to do now this one's going to be a little bit different. We're going to start with, do the first one as static? Yeah. Classic singleton. We're going to make this one a pointer. We'll call you instance. And so now what we're going to do is first we're going to check to see if the classic singleton, if it already has been instantiated. If it has, well, then we're going to do nothing, or we're actually going to return what's already there. If it hasn't been instantiated, well, then we're going to go ahead and instantiate it. So to do that, nope, we already have public. Static. First we have to do this right here. We're going to make a pointer to this class, call it only instance. So now we can say if only instance equals null pointer, which means it has not been instantiated yet, well then new classic singleton return there. So if it hasn't, well then we're going to make a new one of this class and we will return that. If it has, well then we will do absolutely nothing. Alright, so now, so right now as far as creating singletons, we are done. This right here is the Meyer singleton. This right here is the classic singleton. Let's move this back over here. Can I snap? So the classic singleton down here, it uses a pointer and it allows for inheritance. And the Meyers, it does not allow for inheritance. And I read somewhere that you should use Meyers unless you need inheritance, and then you use classic. But as I said, I don't know enough about these to go ahead and explain why that is. But let's go back over here, pick you up, move you over here. Let's actually make these do things. Let's make some variables. Int, do some absolutely horrible variable names. Let's do another horrible variable name. I could leave that as 1 actually, but we're going to go ahead and make it 2 for clarity. And how are we going to get to these? Well, let's see. Void set my int n. So we'll just pass it integer, and then we will make that integer my var1 equals n. Nice and simple. We have a singleton and we have a single variable that we can get in there, and let's print that. Actually, I want you print takes nothing, and we'll print out that guy, then a space there. Let's do the exact same thing over here. We'll be outside of that. My var1 will become dos. And I know since they're in different classes, I could have made these the names the same, but just for clarity, to not make things confused, we'll go ahead and make the names different. And that looks good. I think that's all we need. Let's make a main and let's make things happen. So x equals 2, y equals 3, z equals 4. 1, 2, 3, 4. Well, actually just 2, 3, 4. There, so we have some variables, x, y, and z. M-E-Y-E-R. So we're going to start with Meyer singleton, and we're going to pointer, call you, actually why am I making a pointer? We're going to make the pointer when we go to classic singleton. For Meyers, we're doing a reference. We're going to call you Meyers example 1 if I don't hit the wrong things on my keyboard, and you will equal Meyer singleton instance. So to make this reference, we're going to have to call this static function that is inside of this class. So we use the class the scope resolution operator, and then the name of the function. So now we will have an instantiated Meyer singleton. Let's go ahead and make example 2 so we can see when we edit things in the second one, then whatever changes we've made also is made in the first one because they're looking at the same thing. So first let's do some what I called you set my var1. Well then Meyer's example 1, set my var1, you will be set as x, and let's print Meyer's example 1 dot print. Or actually, know what we can do? We can go ahead and do Meyer's example 2 dot print. There, so we're using Meyer's example 1. We're going to set the variable to 2, and then we're going to use Meyer's example 2 to print, and we're going to see that what we've done in the example 1 will be shown in example 2. Or we messed up, one of the two. I don't know why this does it. Sometimes Control F5 doesn't quite work out for me. So I have to do something that my programming instructor told me never to do, or at least not to do. I remember, is pause in quotes? Yeah, it has to be. There. So that shows that although we used Meyer's example 1 to set the variable, and then we went and we used 2 to print, since we only have one instantiation, that whatever, if we have 3, 4, no matter what we do, they're all going to be looking at the exact same thing. And let's further this bad boy a tad bit. And we're going to make you z, and then let's look at 1 and print. So first thing that's going to happen is it should print 2 because Meyer's example 1 sets it to 2 and 2 prints, and then Meyer's example 2 is going to make the variable 4, and then 1 is going to print. And since they're all looking at the same thing, things are going to print out just the way we think they should. X, which is 2, Z, which is 4. There's the Meyer's singleton. Let's move on. And now we're using classic singleton. We're using a pointer, and I'm going to call you ing classic singleton, and you're going to equal. We're doing this the exact same way since it's a static function inside of the classic singleton class. We'll use the name of the class, the scope resolution operator, and the name of the static function. Actually, you know what? Let's go ahead and make you 1. Make you 2. And let's do the exact same thing so we can show that exactly the way the Meyer's works, the output of the classic singleton. Change you to the output is gonna look the same, even though you can see here that they were set up slightly differently. The output is going to be the same. The concept is still the same. You only want to have one instance of the class, one instance of Meyer singleton, regardless of how many variables we make, one instance of classic singleton, regardless of how many pointers we make to it. So since we're right here, let's go ahead and let's finish this out. Classic singleton 1. I guess maybe I should call it a classic example, but we've gone too far. We'll go ahead, we'll use the arrow operator since we're using pointer, and we're going to set the variable. We're going to make you y because we haven't used y yet. And then classic singleton 2. I'm going to use you to print. And you know what, we'll use 1 to print over there, 2 to change the variable. From y we'll go to z. We'll make z the ending for the 2 examples. Let's go ahead and F5 this. Alright, there's errors. Good. So that means we need to figure out what went wrong. Unresolved externals. Instance. Where is our unresolved external? Only instance. Alright. Oh, okay, good. So do we see what happened here? So right now we have if only instance equals null pointer, then we can go ahead and make the instance of this class. However, we have never set it to null pointer. So let's go ahead and let's do that right now. So we're going classic singleton, pointer, classic singleton, scope resolution operator, only instance, and you shall be equal to null pointer. Now things should work, unless there's something else we missed, but if there is, we will go back and look. So now this part makes sense, because before we never defined only instance. We did inside of the if statement, but that doesn't count because the if statement was looking to see if only instance was null pointer. So now let's go ahead and F5 one more time. And things are working just like we thought they should. Over here, Meyer singleton, it was 2, and then it changed to 3. In classic singleton, we made it 3, or 2, then changed to 4. Classic, then it was 3, and we changed it to 4. And that covers what singletons are. That covers a classic singleton and a Meyer singleton. There are still, this isn't a full complete coverage of what they are. There is still more to learn. So this is just a general coverage of it. We could do a little bit more. We could have made this a vector of ints. And if you already know what's going on, well then you can stop now. I'm going to go ahead and make this a vector just because I'm right here and I think it'll be good just to make it a vector, then see what happens. Using std vector. So now you're not going to be an int, you're going to be a vector of integers. So then we're going to say nope. What am I doing? I don't even know. My var dot pushback. Put some parentheses around you. And then how we're going to do you. Auto e okay, this is pretty much the same thing as saying for, then you put an iterator to the beginning of the vector, and usually the iterator is it. So while it equals myvar.begin or myvar1.begin, while it doesn't reach myvar1.end plus plus whatever we called it, this is a nice quicker way of doing it. And there's no reason to do it for the static or a classic singleton. So now what we have is a vector. And so now we're not going to overwrite when example 1 or example 2 changes it to 4. It's simply going to add it to the vector. Let's go ahead and let's F5 this. There. Of course, I expected it to say just 1, 2 and then a 4, not 2, 2, 4. What's going on here? See, now, if whoever stuck with me, now you're just going to have to be here while I stare at the screen and try to figure this out. Wish I had some music on the side I could play. Give you guys some tunes to listen to. Push back N, so my var1 will be empty at the beginning, and then when we call it, which we're calling it right here, it will be given 2. Oh, that's why. So first it's given 2, and then it's given 4, but the way it's printed out, it's printing out the entire thing. So it's printing out, first it's printing out 2, and then it's printing out 2 and 4. So when we look at it, it looks like it's printing 2, 2, 4, which it is, but we'll just go ahead and comment that guy out. Now we'll look at it. So the vector has, the first element has 2, the next element has 4. That's the way it looks. That was classic Singleton, that was Meyer Singleton. This right here, it shows that it's the only instance of this class, regardless of how many variables we create to look at it. I hope you found this informative. And pretty soon I'm going to do one more tutorial. Then I'm going to do a tutorial where I put a bunch of things together. I hope everybody has a great day. Goodbye.